Let's have a look at question 4. So there's a lot of information here, and you don't need to understand it all first time you read it through, but you do need to have a good idea of what it says. So it's all about Sarah, who's finished university, and she's got a student loan, and it's about how she repays that student loan. So part A, complete the second column in the table opposite. How are we going to do that? Well, we've got the table opposite we'll look at in a moment, but we're told each year what happens to her salary. And pause and just have a look at this recurrence relationship here. If you're not familiar with the recurrence relationships, did you watch my video of it from the lesson the other week? I'll attach it so you can have a look at it again, which just goes over what they are and how they work. But more briefly now, what this means is her salary one year is equal to her salary the previous year, add on 1,500, which is just what it says there, isn't it? Each year, how much it goes up. So there's the table on the next page, and you just say what do you get if you add on 1,500, and again, and so on. So that's 2 marks. You don't need to understand the recurrence relationship, but we'll just have a look at that again once more. So just a reminder, when we've got these little subscript n's and n-1s, that just means it's referring to which year we're talking about. So if we want the salary in year 5, it's equal to the salary in year 1 less than 5, 4 plus 1,500. If we want the salary in year 10, it's equal to the salary in the year before, year 9, plus your 1,500. So that's the recurrence relationship. Let's go on to B. So again, we need to understand this, or we need to understand roughly what it's talking about, and then when you see what the question is, we can go and work out the details. So question B, got 2 recurrence relations which we have to explain why these work, basically. So let's look at the first one, Rn. Well, in the information here we can find out that Rn refers to how much she's repaying off her loan each year. Sn comes up here, it's her salary. So just sussing these details out, you might have to read it through again and just to pick up exactly the little bit you need and make sure it's clear in your head. And so for this recurrence relation here, then it's a relationship between how much she repays and what her salary is. And it's stated that she pays, here we are, her loan repayments are 15% of what she earns above 15,000. So that 0.15, that should tell you that's the multiplier for 15%. And this is the how much more than 15,000 does she earn? What's the difference between what she earns and that? And so she's, once you've worked that out, we find 15% of it. So there we are, dot I1. How about dot I2? L subscript n. So we go back here, what's Ln about? Oh, it's her outstanding loan, how much left she's got to repay. And we're told that the sorry, where are we? Yeah, the interest rate remains constant at 2% throughout the entire period. It's added to the outstanding loan at the start of each year. So here we're talking about, suppose it was year 5, equals 1.02 times the loan at the end of year 4, or the loan in year 4, take away what was repaid during year 4. So if we look at the table, that might just help clarify this. So what we're looking at here is the loan in year 0 at the start is that much. How much is repaid? Nothing. So how much is the loan at the start of the next year? Well, it's not just that. It's 12,000, add on an extra 2%. Okay, so how do we work out what's the loan outstanding in year 2, at the start of year 2? Well, that's how much there was outstanding last year. We've repaid that much, but then you need to add on 2% of what's left. So let's go back to the formula. So that 1.02, you need to recognise that represents an increase of 2%. 2% times how much is left of the loan at the end of the year after the repayment has been made. And so there's my answer. Okay, so let's move on to question C. So it says show clear calculations. So we're going to be writing, not writing down sentences, but calculations. To show that, first of all, the repayment during after that first year, so during the second year, is £150. So here we have it. This is our formula. I've quoted the formula. I've said, right, we want to show what is the repayment, and so I've said in the first year, sorry, in year number 1, her salary is that much. So if we do 0.15 times that, indeed we get 150, which is what we're asked to show. C.I2, so L1, that's the loan that's outstanding after 1 year, and we're told that equals that much. So can we confirm that? Well, let's hope we can. We should be able to. And so what we say is we use our formula, we quote our formula. We say, right, loan outstanding in the first year, how much is repaid during that first year? And lo and behold, yes, it is exactly what we're asked to find. Part D, fill in the table until we find the value of n for which Sarah first owes less than she started at. So what we see is happening here is we add on 2% of what's still outstanding each time. During year 1, we take off 150 repayment and add on 2%, gives us that much. Take off the 375, add on 2% of what's left, we get that much. Still above the 12,000, so we keep going. Repayment is 600 this year, knock off that amount, add on 2%, at last it's less than what she started at. So n equals 4. It's in the 4th year that she's reduced the loan to less than she started.